Telangana Genco Electronics and Communication Branch electromagnetic waves సంబంధించిన క్వశ్చన్స్ మనం ఇప్పుడు డిస్కస్ చేద్దాం. సో I am following master question paper question number 59. The question is the cladding which surrounds the fiber core. This question is related to optical fiber communication. Here the question related to core and cladding, the purpose of cladding is asking. So here we know that an optical fiber consists, this is core medium, and both sides of core, and this is cladding media. Core medium and what is this? Cladding. An optical fiber consists core and cladding. Here core and cladding made with the same type of material, but they have small difference of refractive index. If you consider core refractive index is N1 and cladding refractive index is N2, then there are some rules to propagate electromagnetic wave and to satisfy total internal reflection. The working principle of optical fiber is total internal reflection. So here the question is, I am reading before starting. See, just I explain only one point. An optical fiber consists two media. This is core material and both sides of this core cladding. Now the question is same, the cladding which surrounds the fiber core. ఏమంటున్నాడు? క్లాడింగ్ అనేది కోర్కి బోత్ సైడ్స్ ఎందుకు ఉంది అంటున్నాడు. ఎస్ క్వశ్చన్, దిస్ క్వశ్చన్ is related to constructional of optical fiber question. 4 options given. It is used to protect the fiber, it is used to reduce optical interference, it acts to help guide the light in the core and ensures that the refractive index remains constant. So now I am propagating electromagnetic wave. Here the working principle of an optical fiber is total internal reflection, TIR. Total internal reflection, TIR. So according to this working principle of total internal reflection, when it satisfied the conditions, refractive index of core material is greater than refractive index of cladding material, angle of incidence is greater than critical angle, and denser medium, rarer medium questions. Here very important point, to propagate an electromagnetic wave, through core material only, this cladding will be helpful. అంటే ఇక్కడ మనం ప్రాపగేట్ చేసే ఎలక్ట్రోమాగ్నెటిక్ వేవ్ అనేది కంప్లీట్గా కోర్ మెటీరియల్ నుంచే వెళ్ళాలి అన్నట్టుగా మనం బోత్ సైడ్స్ ఆఫ్ క్లాడింగ్ మెటీరియల్ని కోర్కి చేస్తాం. సో ఇక్కడ అకార్డింగ్ టు రీజన్, it acts to help guide the light in the core only. Option 3 is the correct answer. This is the one question asked related to optical fiber. Next question, question number 60. This question is related to electromagnetic waves. This question is related to electromagnetic waves question. Properties. What is the question? An electromagnetic wave travel in free space. I am considering this is electromagnetic wave. It travels in free space. Only one of the following can happen to them: absorption, refraction, reflection, attenuation. So students, when electromagnetic wave travels through free space, we know that from basic concept, after particular distance it travels in free space only. There is no medium change. After particular distance, slowly the intensity of electromagnetic wave or amplitude of electromagnetic wave, slowly decreases with respect to distance. అంటే ఒక పర్టిక్యులర్ డిస్టెన్స్ ట్రావెల్ అయిన తర్వాత స్లోగా ఏమవుతుంది అంటే ద ఇంటెన్సిటీ ఆఫ్ ఎలక్ట్రోమాగ్నెటిక్ వేవ్ ఆర్ యాంప్లిట్యూడ్ ఇట్ విల్ బి డిక్రీజెస్ because the electromagnetic wave travels through free space only, there is no change of medium. Hence when electromagnetic waves travels through free space, then here only the basic property is what means attenuation. After a particular distance it travel slowly, the wave will be attenuated. Hence option 4 is the correct answer. This is the 60th question. Next question, question number 61. This is also related to electromagnetic waves characteristics. See here, in free space E z of t means you understood that electromagnetic wave is traveling along z direction. Electric field is given as E bar. E bar is given as 50 cos of omega t minus beta z. Omega t minus beta z, what direction is given? X cap. So electric field is in x direction, wave is propagating along z direction, then automatically magnetic field is in y direction. So in free space electric field is given, then is asking average power crossing a circular area of radius 2.5 meters in the plane z equal to constant. Is asking power, but here electromagnetic wave crossing a circular area. So students, in electromagnetic wave characteristics, power can be determined by using power density or by using Poynting vector. What is Poynting vector formula? Poynting vector, it is a vector, it is the cross product of electric field strength as well as magnetic field strength. Poynting vector P bar equals to E cross H watts per meter square. Watts per meter square. We know that if there are two vectors A and B, A cross B equals to AB sin theta. Similarly, E cross H equal to EH sin theta. Angle between electric field, magnetic field is 90 degrees. So I am writing P equal to EH because sin theta, theta equal to 90, sin 90 is 1. Now he is asking average power. He is asking average power. So I am writing average power equals to half EH, of mod E cross H. This is the actual formula. Mod E cross H equal to I am writing half EH. But only electric field is given. So according to the wave impedance definition, eta equals to mod E by H. This is wave impedance definition, eta equal to mod E by H. That means the ratio of magnitude of electric field strength to magnetic field strength is wave impedance. From this concept I am writing H equals to E by eta. H equal to what? E by eta, magnetic field strength. Then I am writing this formula, average power equals to half E square by eta, half E square by eta, because H equal to E by eta. But here power units are what? Watts per meter square, but in answer is asking watts only. So he is given one option here, the wave is crossing a circular area. So what is the area of circle? Pi r square. So I am writing here into pi r square. Then it is watts. So this is the formula to determine average power when wave is propagating, when wave is crossing through a circular area. Now I am substituting the values. See here, half as it is, electric field magnitude is given 50. So I am writing here 50 into 50. And what is wave impedance in free space? That is 120 pi. I am writing in terms of pi because pi is there, pi. And what is the radius of circle is given? 2.5. 2.5 whole square. So pi will be cancelled, and after simplification you will get the answer is 65.1 watts. This is the answer Option 1 is the correct answer. 65.1 watts is the average power when wave is crossing a circular area. Students, next question we are discussing, question number 62. This question is related to transmission lines. This question is related to transmission lines. See here, consider a transmission line. Here I am considering this is a transmission line. Transmission lines means what? It consists two parallel conductors. Transmission line consists two parallel conductors. Here the characteristic impedance of transmission line is given as 50 ohms. So 50 ohms is what? Z0. Z0 is characteristic impedance of transmission line. If the transmission line is terminated at one end by J50 ohms, so here is given a ZR value, it is a pure reactance. ZR receiving end impedance or terminating impedance is given as J50 ohms. So ZR value is given as J50 ohms, characteristic impedance of transmission line is given as 50 ohms. Then is asking what is voltage standing wave ratio? Is asking voltage standing wave ratio equals to how much? This is a direct question. When load impedance is a pure reactive, then magnitude of reflection coefficient is 1. When reflection coefficient is 1, standing wave ratio is infinity. That is answer. But I am explaining here. See, standing wave ratio formula in terms of reflection coefficient, standing wave ratio equals to mod k minus 1 mod k minus 1 by mod k plus 1 by mod k minus 1. Mod k minus 1. Standing wave ratio formula mod k plus 1 by mod k minus 1. See here how to determine magnitude of k. Reflection coefficient means mod k equals to, I am writing formula ZR minus Z0 by ZR plus Z0. ZR minus Z0 by ZR plus Z0. Here ZR value given as J50 and characteristic impedance ZR value is given as J50 and characteristic impedance is also 50 by, and ZR here also I am writing J50 plus 50, all 50s I am cancelling, then numerator denominator magnitude is also becomes mod k equal to how much? 1. When magnitude of reflection coefficient is 1, then standing wave ratio becomes how much? Infinity. So option 3 is the correct answer. Option 3 is the correct answer. Next question, students. This question is related to antenna. A basic question is asked here. Antenna question, this question related. The standard reference antenna for the directive gain. Yes, is given for different antennas. Here directive gain GD, how to determine means to find the power density of given antenna to power density of reference antenna. So here which antenna can be used as a reference antenna to determine directive gain means the correct answer is isotropic antenna. Students, isotropic antenna is the standard reference antenna to determine gain. We know that isotropic antenna is an ideal antenna. It is an antenna which radiates power uniformly in all direction. That is why we are considering it is a reference antenna, but practically it does not exist. When is not mentioned isotropic antenna, generally practically to determine directive gain we are using half-wave dipole antenna is also, but when both options are given in same question, then you must give preference to isotropic antenna. Students, the correct answer is isotropic antenna. And one more question here, which of the following is one is not correct with respect to Faraday's law? This question is related to time varying electromagnetic fields. This question is related to time varying electromagnetic fields. So There we discussed when electric field, magnetic field is varying with respect to time. Till now we discussed electrostatic, magnetostatics, but when we are discussing time varying electromagnetic fields means electric field depends on magnetic field depends on electric field. That means a time varying electric field will be develops magnetic field as well as a time varying magnetic field will be develops electric field. But here the father of electromagnetic induction is Faraday. He explained an EMF will be induced. An EMF will be induced when the magnetic flux phi is changing with respect to time. The rate of change of magnetic flux, due to the rate of change of magnetic flux, an EMF will be induced. We know that is the statement of Faraday's law. Now he is asking question related to Faraday's law only, but is asking which is not correct, in the following four statements. Read first statement. When a changing flux is linked with the circuit, an EMF is induced in the circuit. Just now I told this is the only statement. Whenever a conductor cuts across the magnetic lines of force, an EMF is induced in it. Yes, exactly, it is also correct. The value of the EMF induced is directly proportional to the rate of change of flux linked with the conductor. Yes, exactly, it is also correct. Now, statement 4. The EMF induced in a conductor is inversely proportional to the rate of change of flux linked with the conductor. It is wrong because it is directly proportional to the rate of change of magnetic flux. Hence, is asking which is not correct. So, out of these four options, option 4 is not correct. Not correct statement is correct answer. So, option 4 is the answer, students. 64th option 4. Next question. This is the basic question is asked, that is also related to magnetic side. What is the units of permeability? Permeability mu equal to, we know that mu naught into mu r, where mu naught is absolute permeability, mu r is relative permeability, and the units of permeability is what? Henry per meter. Henry per meter is the units of permeability. Hence, option 4 is the correct answer. Thank you, students.